Example 1. Find the sum of the first 60 terms of the series 5 plus 8 plus 11. So we're adding things up, so it's a series, and this is going up by 3s, so this is an arithmetic series. So we're going to be able to use the formulas. So let's get some values here. Oh, this is actually a part A. We're going to do a part B next. This is a part A. So A is the first term of our series, and that's going to be 5. And D is going to be 3. So what we know is we have Sn equals n over 2, 2a plus n minus 1 d. And what we want is we want the 60th term. So if we want the 60th term, at least for this part of the question, n is equal to 60. We want the sum of the first 60 terms. So that's going to be 60 over 2. A is 5. N is 60. And D is 3. So that's going to be 30 times 10 plus 59 times 3. I think it's 137. Yeah. It's 30 times 10 plus 177, which is, I don't know why, 30 times 187, and 30 times 187 is 5,610. So the sum, putting that all together, the sum of the first 60 terms of the series is 5,610. Okay, let's do the same thing. So this one over here, it's a different one. So in this case, A is going to be equal to 13. D is going to be equal to, so it says pluses in between, but what's really happening is as we're going through each one, we are going down 2 and down 2. So therefore, the D is actually -2. And just like the A, I mean, we have our two formulas, but we can't use this formula because we don't know our last term. We don't know the nth term. So we're going to stick with this one because we know A and D. So once again, S60 is going to be n over 2 times A, which is 13, plus n minus 1 times D, which is going to be 30 again, 13 plus 59 times -2. So that's going to be 13 minus -105 times 30, which is -3,150. How do a bunch of positive numbers add up to such a big negative number? Well, they don't stay positive for long, right? Because it's 13, 11, 9, 7, 5, 3, 1, -1, -3, -5. And in fact, most of the 60 terms are negative numbers. So we're not that surprised. So the sum of the first 60 terms of this series is going to be -3,150. Find the sum of the following series. So 5 plus 9 plus 13 plus all that. Now, what we have here is we have A equals 5 we know D as well. D is 4. This 201 we could describe as T of n. That's going to be T of n. And we actually, in this case, could use, well, we don't actually know how many terms there are, so we can't, we're going to have to figure out how many terms there are, because both formulas need an n. So we're going to have to work that out. So we're going to have to do kind of a mini thing. How many terms? And we've already done that in a previous lesson. So to figure out the number of terms, we already know those things. And we know that T of n equals a plus n minus 1 times d. And so the nth term is going to be 201 equals 5 plus n minus 1 times 4. So 201 equals 5 plus 4n minus 4. And 5 minus 4 is 1. So 4n plus 1. 4n equals 200. And divide both sides, n equals 50. Okay, so now we know that there are 50 terms. So we could kind of add that to our thing. And we're out of space, so we're going to go to the next page. So just to summarize, we know that a equals 5, d equals 4, t of n equals 201, n equals 50. And we can actually use either formula because we know these three things and we know those three things. Let's use the top formula. So we're going to say that the sum of the first n numbers is going to be n over 2 times a plus tn, which is going to be 50 over 2, 5 plus 201, which is going to be 25 times 206, which is 5,150. Or, let's do it the other way too. Or, Sn equals n over 2 times 2a plus n minus 1d, which is going to be 50 over 2 times 2 times 5 plus 50 minus 1 times 4, which is going to be 25 times 10 plus 196. So 25 times 206 is once again 5,150. So either way, the sum of the first 60 terms of the sequence, or essentially, or the series that ends in 201 over there, is going to be 5,150.